All right, welcome. So in this video, I will go over the questions in exercise 1C from the supplementary handout on sum and product of roots. All right, so first question, we need to find out what the sum and product of the new roots are. So we usually, or I usually, start off with writing what the original roots are, the sum and products of them rather. Then I construct the new sum, which is and the new product. So therefore, the new quadratic equation could be in the form of this. Second question. So the original sum and products are as follows. And the new sum is this. New product is that. So we can write x squared minus new sum plus the new product. Oh, there should be a negative as well. There. If they want integer coefficients, all you got to do is to times the whole thing by 5. And you will have this here. Not necessary if the question doesn't ask for integer coefficients. All right, original roots sum are 9 and product 5. So the new sum is 13. And the product is 5 plus 18 plus 4 is 27. So we can form this equation. All right, this time we have a non-coefficient of 1 in front of the square term. So just be careful when you write down the roots. This should be negative 5 over 2. And the product will be negative 3 over 2. Then everything else is the same. Is this correct? Yes, it is. And the product so the equation is that. Again, you can multiply everything by 8 and make them all integer coefficients. Does it integer here? Oh, it does. So for this question, because it's a integer coefficients, we do have to multiply by the 8. There you go. Same as the next question. So the original sum is positive 6 over 3, which is 2. Product is, product is just 1/3. So the new roots are, so this will be a alpha plus beta, or cube, minus 3 alpha beta times alpha plus beta. Okay, it's 2, 1/3, 2, and this is just like before, right? So an equation will be, and then we need to multiply everything by 27. It's 27 times 6, 162. Which question are we on? 6. All right, original sum is -2. Product is -1/2. So let's add them. Oh, don't know why there's an extra 2 down there. And then we can substitute. This is -1/2, right? Okay, we gotta be a bit careful here. -2 times 1/2 should be a 1 here. And then divided by -1/2 is the same as multiplied by -2. So this should be -10. Okay, just a bit of a fraction manipulation there. And we also need to solve for the new product. And what do you know? It's just 1. So the equation will be x squared plus 10x plus 1 equals 0. And they're already integer. How nice. Okay. If you have been watching my video, you should know this by heart now. And before we start, let's just write down what the original sums and products are. This should be 6 over 3, positive 6 over 3, which is 2. And the product will be -2 over 3. Now, to construct the new sum, first we have this. So, now, actually, in part A, it asks for the value. So, what should I really, well, how should I do this? Can I just move this down a little bit and then put this part back up here? And then now we can actually substitute what these parts are. This will be 4 plus 4 over 3, which is 16 over 3. So if you do it like this, then you can skip this part where you have to manipulate the alpha plus beta plus 2, because I already know this is 16 over 3. Right? Because it's from this number here. Otherwise, you can actually just write it as the expression on the top and follow through with it. But this could be a nice time-saving strategy if the question asks you to find a value of some form of alpha and beta first. In which case, usually you have to use it once, or I think in this case twice. So just to make it even more obvious, this is a perfect square. Now this, again, is what we did in part A. So then if we substitute, we have that should be, let's just write out, 52 plus 961. And what integer coefficient? So this time it does an integer, so we can just simply write down x squared minus, what's part A? Sorry, I mean 22 over 3. I mean this number here, not part A, this number here. So I'm looking at these two numbers. And then plus 61 over 9 equals 0. Why are you all the way over there? Okay, so let's just start off with the sum and product. It's alpha plus beta inside, so we can substitute. And what is that? 9 times 7. Ooh, not nice. Not nice. That's 686. 686 plus. Let's write down. All right, so now we can form the new equation. First, add them. So the top part is just what we did in part A. And the bottom part, it looks like that. I'm just going to take the reciprocal of that. And this will be the answer. Okay, it's not divisible by 3, so it's definitely not divisible by 9. And then the product is actually quite nice. If you don't realize it yet, they actually cancel out with the 1 on the bottom. So therefore this will be the reciprocal. So the equation could be in the form of this. Did they want integer? Yes. So multiply everything by 9. And are we on to question 8? No, we are already on 8. 2 more. All right. The original sum is 2 over 5. Product is 4 over 5. So the new sum is, so this is just alpha plus beta all squared minus 2 alpha beta. Bottom is alpha beta all squared. Just a bit of calculation. (16 over 25, right? So on the top we have negative 36 over 25. Now I know that if we divide it by the same denominator, then I could just take the numerator and divide them. You can check that yourself. And the product, it's simple enough because This is just alpha, beta, all squared. And if I correctly remember, that's that. So I can take the reciprocal, and that will be the answer. And a quadratic equation will be that. And I'm guessing they want integer coefficients. Yes. So multiply with index 16 and answer. All right, last question doesn't look as bad. So we have -4. It's not bad because there isn't a coefficient in front of the square term. So the new sum I'll just put alpha plus beta in this set of brackets so you see that I'm substituting. So this will be a -4. And 24. So we do a bit of FOIL expansion. So first term is just a perfect square. Second term, it's this here, so I will write it like this. And then let's substitute. I forgot what they are. -4 and -6. So there's -6. This is -4. This is -6. This is -4. And this is -6, right? Just checking. Yes, 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 yes. Gotta be really careful because I don't want to make a mistake or have to do it twice. That's -64. 18 times 4 is 72. That's a minus. And that's a -6. So we have, I'll just minus the 6 first, so it'll be just 30. And then the 64 plus 72, which is this number here. So that should be that. So that means the equation could be x squared minus 24 minus 106. So 24 comes from here again. And then we have equals 0. And that's it.